Hello, welcome to this webinar, part of the Summer of Chameleon series. My name is Jason. I've worked on Chameleon for quite some time, and most recently have been working on this thing we call Chameleon Edge, which is an extension of the Chameleon testbed to facilitate use cases around edge computing and IoT research. This is a relatively new sort of flavor of Chameleon that's only been around for about a little over a year now. So it's pretty exciting, something new, and we're going to talk about all of the cool things you can do with it, things that we're sort of thinking about for the future, and hopefully inspire you about things that you can do with the testbed, and maybe get some feedback about things that you would like to do that maybe don't seem like this version of the Edge testbed would support, so that we can make changes and help to accommodate all kinds of cool research in the future. So yeah, hide the Zoom thing. Great. So for those of you who are already familiar with Chameleon, or perhaps not familiar, I guess it just helped to maybe just describe what is important about an Edge testbed. So right now, what we have is the ability to basically have a bunch of different Edge devices enrolled into the testbed that allows you to reserve them for exclusive access and share access to them in order to perform experiments. We have one sort of deployment that's called the Chameleon Edge virtual site, which you can log into if you have a Chameleon account. It uses the same federated identity system, meaning that you can just log in with your host credentials. But the kind of interesting thing about Chameleon Edge is, in comparison to a normal cloud deployment where cloud operators buy a bunch of hardware, assemble them into racks, host them into some data center, and the cloud operators retain control of the operations of that hardware, and hence have sort of single ownership of the hardware, like we're the ones who have physical access. Chameleon Edge inverts this paradigm a bit, and it allows mixed ownership. What this means is that while we have purchased some single board computers like Raspberry Pis and Jets and Nanos, we also allow you to purchase them yourself and bring them to the testbed and let the testbed kind of manage them while retaining physical access. So this was kind of really important because with recognizing that really we are not going to be able to anticipate all of the possible ways that you would like to configure your Edge device. So Chameleon Edge has the assumption that you, as the device owner, want to deploy the device to a certain location. You want to hook up certain additional hardware to it for instrumentation, for sensing data around the environment. And this allows you to do that. So you can basically customize your devices to your content, and then enroll them into the Chameleon Edge testbed and take advantage of what the testbed can provide, namely the ability to manage sharing access to the device, manage provisioning code, tearing down code, and handling all of this in a secure way that's also very friendly to a variety of networking situations. And as I already said, because Edge is such a new area of research, in particular, it's new in terms of testbed support, it's really important for us to get feedback from you about the types of experiments that you're interested in doing, because we're still learning about this as well. So talking about this mixed ownership model, this is kind of what I mean. So before, on the left, this is what your standard compute rack looks like. We have a bunch of these hosted at our various host institutions, but Chameleon Edge is a bit different. We can basically take little devices like this little Raspberry Pi rack, which was assembled with the help of my cat at home in my apartment. And these can even be hosted in your home, in your office, in your institution, wherever. In fact, some of the devices that we have on the testbed are plugged into residential environments. One of them is in my apartment around here. So when it comes to so the utility of CheatEdge as a testbed environment is really one about helping you navigate the experiment workflow and making this quite seamless and a pleasant experience. So you don't have to worry about all of these steps, which are normally a little bit difficult to perform reliably if you're just basically trying to use a device directly. So for the first thing, we have the ability to allow you to discover which resources are available, see which ones can I have access to now versus like maybe in a few days, like when is their capacity, what attributes do the device have, and learning more about just what's available. Secondly, as I mentioned, you have the ability to reserve these devices. If you've used Chameleon before, you're probably very familiar with the fact that we provide performance isolation via you have exclusive access to a piece of hardware. We've extended that concept to the edge. So yes, you can actually reserve a set of Raspberry Pis, Jetson Nanos, whatever compute boards you have. And you know that you or the members of your project will be the only ones who are going to be on that device. So it's effectively kind of a single tenant model if you want for that amount of time. Although if within your project you want to let multiple people use the device at the same time, that's also possible. As part of this allocation, we also provide sort of more expressive ways to say like, oh, I just care about, I need like 10 devices. I don't really care about what properties they have. Or for my experiment, I need one with a camera attached. The reservation system allows you to do this quite easily. Once you have the resources, you want to do something with them. And right now with CheatEdge, that is performed via provisioning containers on the device. And again, if you're familiar with containers, if you've used Docker before, a lot of how you interact with CheatEdge will look quite familiar. And I think that when I go through the demo, hopefully that becomes apparent. One of the nice things about it working this way is that we also can support you bringing your own Docker images. So they can be published publicly to the Docker Hub, but importantly, it's also possible to have support private registries. So if you have some data or code that you don't want to publish publicly to the Docker registry or to the public Docker Hub, you can actually, if you have a private registry, put it there. And then CheatEdge, we have a way that you can basically configure it to pull in the data from your private registry. There's a few other ways that you can also integrate with the testbed. Again, if you've used Chameleon, you'll know that we have a few different interfaces. We have a graphical user interface, we have a command line interface, and we also have Jupyter. And because CheatEdge is an extension of Chameleon, that also extends. So you can interact with the testbed in a few different ways, depending on how you like. And I'm going to be showing two such ways, the graphic interface and the Jupyter interface, as part of this demonstration. And lastly, you can monitor the device, you can collect data, you can push data off of the device. We don't really make a lot of assumptions about how this is done, with the idea that people will have many different opinions about what is useful. So we sort of leave it here as like, this is something that you can do in a variety of ways, depending on your experiment needs. So just to compare and contrast the sort of original offering of Chameleon, which is bare metal reconfigurability. CheatEdge differs in some way. We have reservations, but they're for devices. We do container deployments as opposed to bare metal, which means you don't have, we're not able to image the entire device with CheatEdge. It's part of a trade-off for security and ease of management of the device remotely. You do get single tenant isolation though, regardless, because of the reservations. One of the biggest differences is we, like I said, can support devices located kind of anywhere in the world. They don't have to be in a data center. And that's probably the most important thing, is that you can actually bring your own device and manage it yourself. So I've talked about a lot of this already. I'm not going to go into strong detail about this again, just to reiterate what's possible. And I will say that we do have NVIDIA Jetson Nanos and Jetson Xaviers that we've acquired and have made available for you all on the testbed. So many people are interested in those because of the onboard GPU, which you are able to access via the testbed. And I might be able to briefly show that during the demo as well. And the last note I wanted to make was to sort of tease apart this notion of bring your own device, because we actually support kind of two different ways of doing this. Once you enroll your device, you have the option to be like a true sort of citizen of science and allow other researchers to use your device for their own research. Of course, you are still able to reserve time on it, but it just means that other people can actually use your device for if they need more scale for their edge deployment. So that's nice, but it's not required. You can also take your device and make sure that only your research group has access to it. And that's pretty powerful. This is a kind of a new thing that we haven't done before on Chameleon. It really means that the testbed is more managing your own hardware, and it's not really a sort of central pool of hardware. But the cool part about that is you can still grant access to, for example, somebody reviewing your work during artifact review. They can still, even if they don't have physical access to your device or they're not in your lab group, you still have a way that they can come in and reproduce your artifacts via the devices that you've enrolled to Chiad Edge. So it really makes the sharing and the access of the device much simpler than if you were to try to solve these problems yourself. Now that we have an Edge testbed deployed as part of Chameleon, this also means that we've opened up the opportunity for doing edge to cloud experiments. And this is something that a lot of our users during the first few months that we had the Edge testbed operational were really interested in. For example, this little inset image is from a student who was using the Edge testbed to sort of measure some performance about collecting underwater camera imagery and analyzing it for the purposes of doing automated fishery population surveys. So looking at basically, if we have the Raspberry Pi device, it's not able to do very good inference locally, and it's like sending the data up to the cloud to do inference, versus having a Jetson with an onboard GPU would be able to perform inference on board the device. So those types of experiments are now possible with from the same testbed interface as the rest of Chameleon, which is quite nice. And just to mention another example of this, there is an upcoming workshop, CC Grid Cloud to Things. One of our, I think, students from last year took that work and extended it into a larger paper called Automating Edge to Cloud Workflows for Science. And it just was awarded best paper. So that's really cool to see that we're enabling this type of work. Okay, so I've probably chatted for plenty long now, and it's time to sort of show some of what I've been talking about. So let's see what we can do here. So probably the easiest way to just sort of show you how to get started. If you go to www.chameleoncloud.org, if you do not have an allocation, there's a whole process for doing that. But if you do have an allocation, you could sort of follow along with what I'm doing. Although I'd maybe request that sort of just watch so that we don't run into any contention issues while I'm giving the demo for everybody's benefit. But here we have a notable link that describes a little bit about Chiad Edge. This is kind of like your front door to a lot of different resources describing how it works. One thing to point out here is we do have a Google group that describes, it's a users group, so anybody who's using the testbed can come here, ask questions, report problems if you have any, and we also use this to announce new capabilities. So definitely check that out. We also have a resource page that describes the various hardware items that we've purchased and give some information about their capabilities so you can understand what is already available there. We have some detailed documentation about how to use the test bed. But really, let's just jump into the GUI for the rest of this demo. So if you have used Chameleon before, this is going to look quite familiar. It uses the same interface conventions, but instead of us having this instances area here, we're launching either VM instances or bare metal instances. We're instead operating with Docker containers as our abstraction. And so when you come in here, that's where you land initially, and you see whatever containers you might have running. Now, I did mention that you need to reserve access to the devices in order to use them. So that is done similarly to bare metal reservations via the leases section. And you can see what's available by going into the device calendar. And here you can see all the devices that we have available on the test bed. The green line indicates like now, and which ones currently are reserved. So I've reserved like a few for the demo, and I'm going to show you how to make another reservation right now. So let's say I want to reserve a Raspberry Pi. I'll just have it for 1 day. And yes, I want to reserve the Pi. I'm going to now, you can basically filter on which resources you want to reserve. And I'm going to use machine name, which is nice because it just breaks the list up by hardware type effectively. And I'm going to choose this Raspberry Pi 4. And I believe there should be one in the system. So it should be able to obtain that. And now the lease will be pending. It'll eventually go into active state in probably a few moments. And we can see in the device calendar that there should be a new box on one of the Raspberry Pis, which might be this one. Oh no, it would have been really close to the line, so it's this one. And it still is waiting to start. So I'm going to copy this reservation ID because I'm going to need it in a second. Once the lease becomes active, there we go, I'm able to actually use it to launch a container. So that's what we're going to try doing now. So from the container section, I can just do create container, just do JSON RPi4 test. And like I said, you can use any Docker image that's on the Docker hub, the public hub, but you can also bring private registry images. I'm not going to show private registry images right now because it takes a little bit extra setup, but we have documentation for how to accomplish this. And so I'm going to launch this image that just basically opens a Python interpreter. It doesn't really do anything that interesting, but it'll demonstrate the capabilities. I'm just going to show you a few things. So a lot of these options are going to look familiar if you've used Docker before. You can, for example, throttle CPU or memory or disk quota if you want. Most users opt not to do this, but it's a possibility. If you're exposing some network services to your container, security groups manage basically ingress and egress to and from the container. We're not going to do that for this demonstration because I'm just going to be showing you how to sort of execute commands and look at the console. But this is important if you're going to be doing any sort of network service experiment. You can also change which working directory the container launches in. This can be useful in some ways. I think the Jupyter demo later will show. The main thing, though, that we need to do is provide the reservation that we made, put the ID there, and this just lets it know that it's going to launch this container onto that Raspberry Pi 4 that we just reserved. Now, this might take a little bit of time to do because, oops, it might need to download the image. So I'm going to actually jump over to another one that I did. The good part about this is if it's the first time that you're launching the image, it will take a little bit of time for it to download it to the devices, image cache, but then subsequent times, if you want to try again, it's significantly faster. So looking at other things that we can do with the container. So I have here, actually, this is a container that should be running on top of a Jetson Nano. And I'm just going to show you a few things you can do with containers that are already running. So one thing you can do is you can just run one-off commands, which can be helpful if you just want to sort of inspect something, do some sanity checks. If you have like an experiment that maybe you want to capture this output easily, that's something that there's a simple mechanism for, both in the GUI and in the Python and CLI interfaces. You can also capture logs from the container as it's going. If you have like a service that's running in the container and it fails or it's outputting some interesting data, you can capture it here. In this case, this is just has opened a shell, so there's kind of no logs to show up there. One of the cooler parts about this, though, is that you have a really pretty snappy interactive console. This is running inside the container on that device, wherever that device is, and you can use it just like a regular shell. So I'm just going to pop into a bash shell here, and this one is the Nano, and I'm pretty sure that this this image that I have has some of the CUDA utilities on it, such as this device query utility. And that's just kind of is probing the device for, where's the GPU and what are its properties. And this just kind of maybe, proves the assertion that, yes, the GPU is actually available for use from inside of the Jetson Nano and Jetson Xavier hosts, which is pretty cool. So that's kind of the general quick overview of some of the things that are possible in the GUI. I did want to spend some time to show you another interesting interface, which is the Jupyter and Python interface, because some things are easier to do with that interface, and it can also help you express an entire experiment in kind of a nice way using Jupyter notebooks. And for that topic in particular, if you're watching what I'm about to show with the Edge Jupyter demonstration, if you're interested in learning more about these Jupyter capabilities, there's another webinar that starts at 3 p.m. today Central Time. So just an hour after this one ends. And I'm going to be going over that in more detail, as well as some other interesting things that Chameleon has for reproducibility. So that's just a little plug. But let's go back over here. What I was going to show is the stuff that I'm about to show you is available on what we call Trovy, which is our collection of these sort of Jupyter Notebook experiment reproducible examples. And again, this is what I'm going to be showing a little bit later today. Specifically, the one that I'm demonstrating is the Chameleon user guide, Edge, which goes over a lot of the capabilities of the Edge testbed. So when you come into this environment, we have a notebook here that is, we're going to do a few different things. We're going to be launching containers, interacting with them, and demonstrating some more cool stuff. And to do that, I'm going to be basically invoking the Edge API from inside the Jupyter notebook and then taking output from it and displaying it here in the notebook. So I've already, to save some time, I already did a lease for a Raspberry Pi, and I'm going to be doing some demonstrations on that. So what we're going to do is we're using right now a Python library that's actually been customized for the Chameleon testbed to make certain things simpler. It's called Python G. And you can find that's an open source project. You can use it either inside of this Jupyter environment, or you can use it just on your local machine if you want. But it provides some really handy utilities for using the various testbeds that are part of Chameleon, and Edge is no exception here. So In particular, we've got this container library here. And one of the functions that's quite useful is the one that creates a new container. So here you can see I'm going to create a container that's going to be called this. It's going to use that Python image again. But there's a few new things. It's going to, instead of just using the default Python REPL, it's going to actually launch an HTTP server on this port. And it's going to be serving the contents of this directory. So this is a directory that the container is going to be executing Python in the context of. So it's going to be serving the content of this directory. And lastly, I need to specify the port that it's going to expose so that I can actually get traffic on that port. So I should have started that earlier so that we can watch this. But just to kind of prove that this is interacting with the testbed, though, I can actually go back to CheatEdge, and I can see that, hey, there's my web server container right there. Very cool. And in fact, yes, I come back and it says that it's finished launching my container. So now I said, like, yes, you can do things like executing one-off commands, and that's what I'm doing right here. Right now, I just executed that against the container, and it's looking at its the value of that directory, which is nothing there. Not very interesting, but this is kind of cool. So after sort of in the back of your mind, remember like where this device is. It could be anywhere in the world. Like one of these is, you don't even have to have publicly addressable IPs on all these devices. They can be behind firewalls. They can be behind NATs. But the testbed has the ability to make them addressable if you wish. So we've extended the floating IP capability such that, if this works, yes. So this is actually a Chameleon public IP address. And now traffic that hits that address is actually being routed straight down to that container running on the device, wherever that device is. And in this case, it's serving that HTTP. It's running that HTTP server, which is serving the contents of that folder, which are empty. Okay, so the next thing we're going to do is put some stuff there. So over here in the Jupyter Lab environment, I have this web server folder, and it's got this file that is just basically saying, yes, hello from CheatEdge. It's just a little HTML file. So I can actually take that and upload it to my container. And I'm going to basically take the contents of this, upload it to var.dev.html, and then I'm going to run ls on the container. You can see that the file is actually there, which means that I can actually visit it now, which is quite cool. Now, I can also, this is one of the nice things about using the Jupyter environment is it allows me to really rapidly kind of iterate on what I'm doing. So I can change the file. Now I can refresh and I can get that new contents there. And all this is happening from within the IDE. I can sort of edit files, I can upload them and interact with them remotely. It's all very nice. So I'm going to now just bring that container down, and we're going to do a slightly more complicated example using a few other bits and bobs. So this example is setting up two containers, and it's using a kind of frequently used pattern in Edge and IoT experiments where you're sending events usually over a lightweight protocol like MQTT. And a lot of like sensors and IoT devices use this to transmit data back and forth, and sometimes even exposing RPC. Anyway, what we're going to do is set up a MQTT server, which is just going to sit and accept connections. And we're doing a few different things here. So we're using that create container function again, but now we're using a different image that's available on the Docker Hub. And it is going to, expose the ports that we know MQTT is expecting. But the new thing here is we're actually providing a configuration file that can be mounted inside the container when it's created. So if you've used containers before, this is kind of a common pattern where the container sort of is more or less of a generic image that can be customized at runtime, usually by providing environment variables or configuration files that are mounted at some well-known location. And the MQTT, or rather Mosquito image, works very similarly. So it expects to find a configuration file at this location, and then we're providing it basically. And that file is here. It's just basically saying, yeah, I'm going to listen on this port. I'm going to actually turn off authentication for the purposes of this demo. Of course, not recommended, but it will. The cool thing is, just like with the previous example, it's actually locally stored here in the Jupyter environment, and I'm opening that file from within Jupyter and then just passing it source on the mount. So that's pretty nice. It means I can change the configuration and relaunch the container all within the environment of Jupyter. So while I've been talking, that server finished, and we are also able to get the value of its private IP address that was assigned by the testbed. So now if I went to this address, it's not routable because it's a private address, but it's important to have this because we're going to use it in the next step. The next step being, we're going to now, we've basically spun up this message broker, which is going to just sit there and collect messages. And we can also later pull the messages off of it, which we're going to do. But now we need to start sending some stuff there. So we're going to spin up another container, which is going to publish to that. So it looks very similar because we're actually going to be using a built-in publish script that is provided by the image. I'm basically going to be running the script inside of that publisher. It's going to be using this Mosquito pub utility. It's going to find the address of the Mosquito host via an environment variable. And then it's just going to basically be sending some random numbers that are generated via awk. So it's just proof of concept. We just want to publish some messages to the MQTT broker at this address. And now we can see that that address is going to work because we're passing it in as an environment variable and using that private IP that we pulled in the last step. So this is another sort of nice part about using Jupyter is you can stitch these two operations together. And I forget if I did this already. Did I run that while I was talking? No, I didn't. So let's start that going. And similarly, we are actually passing in that run script because that's not there in the container by default. And then I'm telling it, yes, run that script when the container launches and start publishing data. The last thing we're going to do is start pulling some data off of that and showing it within the Jupyter environment. So in order to pull the data, I do need to attach a public IP address again, which I just did. And now I'm just using like a built-in, pretty common Python library for connecting to MQTT, connecting on the public IP, just doing a little bookkeeping, and I'm good. And now I can actually take and start subscribing to all the data that's being sent by that publishing process and print it out on this graph. So as you can see, it's kind of doing this little jitter of values. It's generating, just pushing random ints between the value of 0 and 100 to the broker, which I'm then picking up and displaying. So it's a more complicated example showing some more of the kind of cool capabilities you can do. Notably, the remote connectivity capability is really cool, and hopefully gives you some ideas about things that you might be able to do in the future. So I'm going to tear that stuff down, and I've been talking a bit, maybe more than I planned, so I want to make sure that we cover device enrollment. So I'm going to jump back to the webinar now, and hopefully we'll have some time for questions at the end for the stuff I just showed. So that's generally like, yeah, how do you as an end user use the testbed in order to set up and provision your edge topology, your edge to cloud experiment, however you want to do it. What we haven't covered is, well, how do I actually hook up my device? So like I just have this, for example, this Raspberry Pi 3 board here on my desk. It's about the minimum specs that we can probably support on ShadeEdge at the moment. Relatively basic device, but it's something that I could actually hook up and use with ShadeEdge. Anything that derives from a Raspberry Pi compute module or a Jetson Nano or Xavier is currently, I want to say, supported on ShadeEdge. And that's the ones that we've tested rather and evaluated. But any other platforms or modules you're interested in, we'd be very interested in knowing what those are, because likely the step for supporting them is not significantly more than what we've already done to support standard single board computers. Importantly, yeah, you can use any of the additional hats or peripherals or sensors that you want. You can hook them in there and be able to detect and access them on the Edge testbed. And as I already said before, we talked about some of the benefits of like why you would want to use ShadeEdge to manage your devices. It really removes a lot of the operational overhead of how do you manage sharing, how do you manage multi-tenancy, how do you deal with weird networking conditions, like not having network, having NATs, firewalls, whatever. So there's a lot of benefits to just having ShadeEdge provide a nice interface to your device. This is accomplished, device enrollment is accomplished via a command line interface that you can install. It's part of this Python ShadeEdge, what we call the ShadeEdge SDK. And I'm going to show sort of just a little bit about like what that looks like now. I need to actually switch my screen share though, so I can share the right stuff. So with the Edge SDK, let me just make this a bit bigger. So you can see there's a few different options we have available. So you can use this to do some maybe basic things that you would expect, like enumerate all the devices that you've enrolled on the testbed. You can show information about the device, like if it's healthy, various, like we actually ask that you set a contact email address for all of them. If we've detected that there's stuff plugged in that is going to be made available to the testbed, that's all there as well. And similarly, you can register a device with ShadeEdge. So when you're registering a device, we ask for just a few bits of information, notably your contact email, so that if there's a problem, like the device has been down for like a week or something, or maybe if somebody's interested in using one of the public devices, but it's not available, the testbed or us can email you, ask like, hey, what's up? So just important to have a contact email address for those situations. The machine name is the type of device, and there's a certain, as I said, a subset of types that we support currently, but we're interested in what more we might want to do. And the last thing you need to do is generate a special credential on the testbed that allows your device to complete self-registration. And there are instructions on how to generate this on the testbed in our documentation. In this case, yeah, I've just basically registered a device. Now there's kind of an entry placed into the testbed that's going to be holding it's basically a placeholder record for like this device is eventually going to be associated with that. The next thing that you need to do is run this operation that we call bake. And I'm actually not sure if I have the image stored locally anymore. But the what this does is it basically customizes a stock base image for your target platform. It puts some device-specific credentials on it so that you can basically take the final image, the image that's been baked with device-specific credentials. You can then flash that onto an SD card, just insert it into your device, turn it on, and after probably about 5 minutes, it'll just automatically complete its enrollment in the test bed, and you should see it just sort of show up, and you can start accepting reservations on it. So that's generally the process is quite simple, actually. You first register, you create like a record in the test bed. Then from the record, you generate a custom per device image, which you then flash onto the device, and you're off to the races. You can also delete devices if you don't want them on the test bed anymore. Voila. So yeah, I don't really have the time to show like the full device run through, but that's the general process, and we have it documented both in our documentation and in a sort of tutorial video that we put together about a month ago, which is linked in the slides for the webinar. I'm going to go back now to my other window. Cool, and that's the biggest part that I wanted to cover. I wanted to leave some time for any questions. What I will leave you with is, again, a link to the Google group in case you have questions. Again, it's a good resource if you want to just keep in touch, keep abreast of new features, new capabilities that the testbed supports. You should go there because that's where we tend to announce things first. You can also ask other users questions and maybe learn about how other people have been using it. Other resources, I mentioned before that we have this sort of intro video. It goes over how you enroll your device in a bit more detail. You can watch that. You can send it to others that you might might be interested in using Edge to manage their device to make some problems simpler. I briefly mentioned Edge to Cloud. We actually have a pretty nice notebook example that sort of shows how can you use one Jupyter notebook to set up a node on a bare metal cloud on Chameleon, and then set up a container on Edge and have them talk to each other. So just sort of walking you through that. And lastly, we have, as with all Chameleon testbed properties, we really strive to make sure our documentation is pretty thorough, and we have a Edge specific documentation guide linked here as well. So I think that's everything I wanted to cover, and we do have some time for other questions about Edge, what you can do, what you might be interested in. Thanks for giving me the attention, and I'll turn it back over to anybody else who is curious. Okay, I don't know if you're trying to talk, but you might be muted. You're showing up a screen on my screen. Okay, I don't see any immediate questions, which I assume means that I answered everything, which is, that would be great if that's true. That's what we strive for in the webinars. So I think that, yeah, join the Google group if you have other questions that come to you. Definitely play around with it. And I mentioned before, there's going to be another webinar in about an hour, a little over an hour, talking more in depth about the reproducibility and sharing capabilities, which includes some of that Jupyter stuff that I just showed you. I think maybe the other last thing I would mention is regarding the reproducibility stuff, if you're interested in that, but maybe you don't have time to sit in the webinar, you should definitely go to Chameleon's YouTube channel, because we have a nice set of videos from students who have used Chameleon to package and reproduce experiments. And you can find a collection of them there, demonstrating, what you can do and how it's possible on Chameleon. So thanks.